Good afternoon. This is somewhat an odd presentation on an Icinga camp, but when I'm finished, you'll probably realize why I'm talking about this topic. For those who don't know me, who doesn't know me? Okay, well, still. Just Mark and Michael laughing in the back because they've been seeing so much of me. That's because I'm part of the traveling geek circus, which Bernd initially started. It's a bunch of people who meet every single month at a different conference. Still don't know which one is July, but where are we going in July?
I don't know. Can we meet with your conference at home?
Conference at home at Bernd. So I think you just all got invited for a barbecue. My name is Chris. I've been in the IT industry, open source industry for the past 2 decades. I started out as a developer, and then I kind of became an ops guy. What I'm doing today is, as the CTO of Inuit, I'm helping people with delivering software faster with open source. Somewhere along the line, I figured out that everything was the fucking DNS problem. I made the title of my blog. I put it on t-shirts. And since then, every time people run into a DNS problem, like Toys or DNS, Michi in the back, they go like, Chris broke it. So now my response is, Michael will fix it, JP Mens will fix it, but I just point out that it was a problem. I've been doing cloud since before there was a bookstore doing cloud, at least whatever cloud is. And somewhere along the line of helping people to deploy software and helping people to deliver software, I came up with a crazy idea to organize a conference to bring developers and operations people together. That was 6 years ago in Ghent. We called it DevOps Days back then, Patrick and I. And for those who are way too late to register, the next 3 days will be in Pakhuis de Zwijger for DevOps Days Amsterdam. But it's completely sold out, so don't even bother to go. We will be there. That's like all of the Icinga crowd and Toshan and one other guy. So yeah, and I'm part of the traveling circus, which we kind of realized somewhere in London in May that it has been the same crowd. So I said DevOps like 3 times. Who knows what DevOps is? Okay, so who thinks he knows it is, but is afraid to show his hand? Who's awake? What was in the food? Okay, Walter I get because he's a young kid, but the rest, I mean, you should be awake if you're coming here. This is the second slot after lunch, not the first slot. You're supposed to sleep through the first slot. So you've been organizing conferences long enough to realize that. So DevOps. It's a difficult word to explain, but for a lot of people, it comes down to the CLAMS keyword. Damon Edwards and John Willis came up with that term after they had interviewed a lot of people in their podcast called DevOps Cafe. And after interviewing a large number of people, they figured out, hey, there's a common thing between all those people. It's the culture they have in their organizations. It's the fact that they automate everything, and that's pretty much what this presentation is going to be about. It's the fact that they are doing monitoring and metrics in a much more advanced way than what we were doing before, and kind of the combination of automation and monitoring. That's where we are today. And they shared their experiences. They shared their source code. Somewhere along the line, Gene Kim came and he said, well, there's also a lot of influence from the Lean movement, but fundamentally that is what DevOps is about. It's a culture change, it's a movement, it's a journey for an organization towards deploying their software in a better way. So one of the big key components there is automation. And obviously, this talk is about the importance of infrastructure as code, so I'll be talking to you about why you should be automating. And mainly because there's a large number of problems which you are tackling. Who's currently not using any kind of infrastructure as code? Okay, that's fine because I know you're all still asleep. Otherwise, I'd just leave because you already know all of this, right? We're still doing manual changes on platforms. So all of those who just said they're doing infrastructure as code and now show their hand, Nope. A lot of platforms are still managed manually. We have this weird thing where we have told developers, so in order to deploy an application on our platform, you need to have these, and these tests in place, you need to have that in place, you need to have that in place, and we're going to deploy them automatically. But on the other side, at 5 p.m. on Saturday afternoon, you're going to, oh, I'm going to change the memory allocation for that JVM. Let me just shell into a box, restart Tomcat and edit the -x and just be done with it. And then you forget one box. So you have a bunch of undocumented changes. People go onto a box and fix it when something breaks. Your disaster recovery side is pretty much out of sync because you never made the changes you made on the other platform there. So when you finally move over to a disaster recovery side, basically you have a disaster because nothing is in place. And then there's your customers. So show hands, who's delivering machines to end users, to people, to customers? What is the rest of you guys doing? Drinking, coughing, and sleeping, yeah, okay. So if you're asked to build a box, how long does that generally take? Who does that in a couple of minutes? Who does it in a couple of hours? Who takes weeks to deliver a box?
Because it's lazy or because it takes that long?
Because it takes that long. Or because the organization you're working for is completely screwed up. If this room would be on the other side of the building, I would be pointing to a building that takes about 3 to 6 weeks to deliver a VM. They do that in something called a private cloud. That was not a joke, that was sad reality. And when they do that, every single box they deliver is different. So one box will get CentOS 7.1, the next one you request will get 7.2, then there will be some patch levels in between because they're basically doing a lot of stuff manually. And why is that? Well, basically we're humans, and we still haven't figured out that computers are pretty much idle all the time and they should be doing a lot of more work for themselves. So imagine that you have automated a bunch of things. How long does it take for you for a machine to reinstall it from scratch? Anybody? Who does it in less than 5 minutes? So there's a couple of people in here who are constantly saying 5 minutes. I'm like, I'm doing this. It's because they've been listening to me and other people for like the past 5 years. They've even been recording us. By the way, great job. And are you sure if you do that it's going to be back at the same point it was before? Can you do that with different hardware, with different clouds? So you're running on AWS now and you want to do it on DigitalOcean. Can you do that? A lot of people just aren't capable of doing that. So then there's a security thing. If you look at the past 18 to 2 months, 2 years, 18 months to 2 years, security has been hell. I mean, the number of issues we had on kernel level, on SSL level, on all those things, it's been really painful for operation people to deal with that. And we still are not dealing with security in a good way. Who has as a Linux disabled by default? Who has it running? Enabled? Who doesn't know what as a Linux is? Toshan, you're going to replace your talk and do an as a Linux talk later. So yeah, we're disabling as a Linux, and we don't know why. Company policy might be to enable it, but you arrive on a box and it's disabled. Why? Because somebody did that manually. And there's a bunch of firewall rules on a box, and suddenly somebody installs something and adds support and changes the firewall rules, and you figure out, hey, wasn't this supposed to be closed? Or what did this originally look like? How did this file look like? And I mean, this config file, is this really what Bernd put in there? I mean, I don't know. He might not even know, because he'd done it like 3 months ago, and he has no clue on what he did then. So security is something we have problems with. We've spent time putting tripwire in place and then forget to update the policies, and then you saw all the error reports. Hey, this file has been changed. Yeah, I know that. But you have no way to actually define how to put a file in place correctly. And then monitoring sucks. I mean, John Vincent started using this hashtag because he was frustrated with the current state of monitoring. His platforms were completely out of sync. He had added a lot of nodes and they weren't being monitored. He modified services that were not being monitored. And a lot of people had manually updated their monitoring platform. So you have a new node, you go to the UI, you add your monitoring, you add your servers, yep, they're green. And then 3 weeks later, you move the box and somebody says, yeah, we'll change the update, we'll update the monitoring platform later. And it never happens. And it turns red, and you acknowledge it, and then you ignore it. Sounds familiar? Yep. So that's kind of why monitoring sucks, right? We have alert fatigue. So for me, the journey with infrastructure as code started with this rack. Yes, the upper part was a bunch of Cisco's. The lower part, and this was not a full rack yet, was all Linux boxes, which we were building, we were deploying software on there, and we were shipping them off-site. Yes, one of those racks actually fell off a boat and we never saw it again, but these were like back in 2003, 2004, 3 to 4 racks, and the goal was to ship a rack a week. And the initial approach we took was we were manually installing them. At least that's what happened when I arrived. People had manually installed it. And there was OpenOffice on the boxes, and there was X on the boxes, and, well, all kind of stuff you don't want there. And the first time it's fun to install a full rack. The second time it's fun. The third time you're like, oh, this is boring. So you start figuring out how to solve this. So the challenge became, we want to be able to deploy such a stack, and that was over 10 years ago, where it has to be fast, it has to be reproducible, we have to have identical stacks, we need to be able to identify what we ship, what we know. We need to be able to monitor them, have security in place, and we need to do backups and all that stuff. And it was along that time that I came along readings of infrastructures.org, Steve Trogert, and he kind of came up with the idea of a 10th floor test. Who can survive the 10th floor test? Who's from LeaseWeb here? How many floors do you have? 6, you're lucky. So my excuse for a while was that I hadn't found a customer yet with 10 floors. I actually do have customers now with 10 floors. And the thing I figured out there is that they actually have sealed windows because people wanted to jump out of them. So the 10th floor is kind of the idea that you can take any random machine in your infrastructure and throw it out of the window, and nobody should really notice because you're up and running again within 10 minutes because you can re-bootstrap everything. So infrastructure as code is going to solve a bunch of these problems. We need to know that data backup is only part of the solution, that we also need to take care that sysadmins are being backed up so that your peers know what you've been doing. We know that manual installations are bad because they're going to be different each time. They're going to be broken. A bad installation means it's an unusable infrastructure. A bad installation means your users, your colleagues, your paying customers are going to have a bad time. If you have bad installations, that actually escalates because you're going to need to go into those boxes again and fix them again, which means you're doing more manual efforts, which means you don't have time to do the real important stuff like security updates. So you're going to have even more costs. And what happens if you have no security and really high cost to fix stuff? You're going to go out of business. Who wants to go out of business? There's no startups here then. Okay. So let's have a look. How do we solve these things? Because a lot of things we tried and a lot of things we do now is because we learned from the past. And we see that new people are making exactly the same mistakes we made 10 years ago. Back in 1996, when I first started working, basically we had a CD. You guys are old enough to know what a CD is, right? We put it in a tray and then we installed a machine. And then For the next server, we went to the next machine. For the next server, we went to the next machine. And we went like click, 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 enter, enter, enter. Text mode only, of course, and we installed stuff. And we started figuring out, now there needs to be a faster way. I don't need to do all the, because my DHCP server gives me an IP address, and I really don't want to go over the same configs again. So we found out a tool, something like Mondo Rescue. Who's been using Mondo Rescue? Who knows Mondo Rescue? Not from one of my talks. See, hands go down. Yeah, Toshan. Okay. And that was good. You could just go into a machine, and it created an ISO for you, which then would automatically reinstall the box on a different machine. With the same kernel, with the same hardware. And it worked if you had a farm of identical machines. If you were building a Beowulf cluster or so, that was good stuff back in 2001. And then we figured out there's this thing called a network, and we can do this faster. So what about we take it to the next level, and we say we image a box, and then we use the network to share the rest. No more walking around with disks. And System Imager back in those days had a really good idea about, well, there's going to be a lot of stuff identical to a machine, and then there's going to be a bunch of things which are going to be different. And they called that the overrides. So you had varlib System Imager overrides, and per host you basically had the whole structure of the machine there. And you saw most stuff in /etc changing, so you had host name, etc, and then the different files for each machine. So you had network config in there, differences in Apache configs. You kind of build a tree to generate the overrides, because you knew that those were parameters. You started using templates to do that. You start building those. You used multicast or BitTorrent to do fast deployment. But still, what you ended up was you deploy a machine once, and after a couple of weeks' time, you had like, so we built this image, then we imaged it again, and that was basically a basic server. Then we installed the database on top of it, and we did a web server on top of it, and we took an image again, and that was then the LAMP stack which we were shipping. And nobody really knew where you came from. So when the day was there when you needed to update OpenSSH, I was like, oh shit, so that box is that version, that box is that version, these got updates, these didn't. It was chaos. And we started to understand what image sprawl was about. Proprietary vendors were going even worse. VMware gave us the really nice VMDK format, which allowed people to just, here's a VMDK file, that's VM, just copy it. And you saw VMs popping up all over the place. And basically, nobody had control over what was happening in his infrastructure. So fast forward 2 years, we moved away from doing full image installations, and we started taking just enough operating system, kickstart a really minimal installation, or use Phi if you're Debian, and then started actually having a list of packages needing to be deployed on that. And we started experimenting with the very first, well, actually that was already late, infrastructure of code kind of thingies. Back then we did a bunch of proof of concepts with CF Engine. We looked into BCFG2, LCFG, and a couple of other tools, but they were really, really not mature. So we started doing those things. And that was kind of the time when tools like Puppet first started showing sight. So if you were around in those days, Puppet 123, 124, stuff like that, you realized that it was CF Engine on a learning curve like this, Puppet 1 was like this, and then new tools came along, and Ansible is kind of like this. So it was really lowering the barrier of getting involved in those things. Around 2008, we were building just enough operating system and using Puppet on top of it to take control of everything underneath. And then we started seeing the benefits. We started saying, hey, what if we take this image, if we take this minimal image, this small box, we give it to a developer, that's going to be exactly what he's going to run on production. So we now had solutions for image sprawl, figuring out how the fucking machine got in the state it was, but also for snowflakes. Snowflakes are the little boxes that somebody built with no documentation, where you're like, don't touch that box, because if we touch it, stuff is going to break, and we have no clue what's going to break. It's a really nice box, but don't touch it. It's kind of the thing you don't want. So one of the arguments people had to me about why would I even spend time writing code to do something automatically, because I'm only going to deploy a machine once. Those were the people with a lot of snowflakes. And for me personally, there's never something I deploy just once. I don't know about you guys, but I start with taking a tool, I start playing with it, looking around, looking if I like it. So I boot up a new Vagrant box, start writing 5 lines of code to actually put in place all the dependencies. And then I don't look at the box for like 3 weeks. I destroy the Vagrant box because I need space on my laptop. There's like only a quarter of tera SSD disks there, and I've got like 50 projects going. And then 3 weeks later, I'm like, I'm going to pick up that project again and do Vagrant up, and I'm exactly at the same state. So that's already, even if it's a project which I'm never going to put in production, the first time I'm having a benefit from having written the code that deploys something to a certain stage. So when I finish working with that tool, when it makes sense that we are going to use it in a platform, I now have a code base which I can use for development, for further development with colleagues, for a testing platform to show to another person and say, hey, this is what we're setting up. Is this something you like? And to eventually go to production. It's going to have different parameters, but it's pretty much going to be the same code base. And we use exactly the same code base for disaster recovery, so we get that for free. And then there's the same customer said, no, you're not going to do infrastructure as code for us. You're not going to do this. And we're like, so this is default LAMP stack. They want us to set that up. Yeah, we'll have the full code for that. We're not going to tell them we're doing, but we're going to do that. Why? Because by the end of the year, they actually forgot to renew the lease on their server. And they called us on a Friday evening. Yeah, what's the problem? Yeah, our server is down. Yep, that's right. It's gone. What do you mean it's gone? So you know that contract you guys signed with that supplier? Yeah. Did you renew it? No, should we? Yeah, because that's what your server is for. So their server was gone. Do you have backups? Yeah, we have some backups. But you can configure it again, right? Sure. Because we used infrastructure as code, after they figured out who could actually renew the contract because nobody had a corporate credit card, and that took them half a week, it took us 2 hours to boot up the box again and bring it back to the state it was. The next time we had to go in there and do something was, well, infrastructure as code. We were allowed to actually write the code for their stack. So you need this in order to be able to recover if your stupid finance department forgets to renew your server leases. So that's single nodes, that's development environment, that's us experiencing that the ultimate dream we had back in the early 2000s, where I was trying to deploy 5,000 firewalls, kind of identical. We were now at that point, but we never had the need for 5,000 firewalls. Europe still doesn't do public cloud, but scale is not about deploying 5,000 nodes. It's about the complexity of deploying really a lot of different services also. But when you have those 5,000 nodes, you're really happy you've done it in a way you can automate it. You can go much faster into introducing changes into those boxes. And that's important. So now with infrastructure as code, we can think about our machines differently. If there's a sick animal in there, you shoot it. You don't risk the other machines to go down. You just replace it. And we can actually improve the culture in the organization by having our team members being treated as pets. Give them some ID. So when we were doing the exercise about the 3 racks, we figured out that once we needed to do 40 nodes, 50 nodes, we had about 1,500 files per node that we wanted to modify. So we needed tools like Shift or Puppet. And we realized that we needed to put them under version control. I think I'm probably one of the only guys in the world who ever said, please don't roll your own. And I said, except for you, you, and you. And that was Mark Burgers, Thomas Hatch, and Luke Anise. I think I actually had it with Adam Jacob too. So don't roll your own unless you're one of those guys. I think Michael DeHaan was in the room also when I said it, and he ignored my So infrastructure as code means that we are treating configuration automation as code. We're going to treat the way we build machines as if we were writing code. So you write a module, a cookbook, a recipe, which kind of takes standards in your infrastructure. And then you add exceptions to that with your parameters. So you build a module, and then you use version control, and then you start writing tests. Who's still following me? Who's writing tests? Not too many people are writing tests. So there's a big discussion going on about where you should be testing. If you're in a Puppet or Chef ecosystem, a lot of people are putting a lot of effort into writing unit tests. But you could argue that there's much more value into writing actual integration tests that you can reuse in your monitoring platform. Because yeah, Apache running on port 80, that's cool. If you write Puppet or Chef code which actually set up your server on port 80, awesome. But does the business functionality inside work? That's the important part. So now you have a modular infrastructure, which is versioned, which you can actually build out a full stack from. So a working service which you're offering to the end users now is the combination of your application code, the infrastructure code, the security policies you write, and the monitoring code you generate because of that. In the early days, I had to explain to a lot of people that that is not the same as writing shell scripts. Because shell scripts tend to be spaghetti and tend to be not being reused by anybody else but the guy who wrote it. I had to add to that if you translate your shell script, your bash, to YAML, you're still not doing infrastructure as code. I think there's a couple of people in the room who know what I mean. The others, you'll figure it out. The other part is when you build this, you basically have your hardware. Whoa. You have the operating system, which is coming out of your Kickstart by default. You can automate your middleware and your databases. You can automate the application deployment. And that's a full stack which is versioned. That's an artifact which you can ship to your pipeline, and then you can add an environment configuration to that. You say, this is the build, and now we add data to that build, and that build becomes development, that becomes production, that becomes shadow production, that becomes disaster recovery. And you can scale that out. And in a way, if you are dealing with software delivery, if you are dealing with people who do tests, this is a business requirement. You need to be able to boot up a box, boot up a full environment and say, look, if you want to start testing your software, start here. If your end result becomes the same each time over and over again, then your tests are valid. But if you each time start from a different starting point, you have no clue where you're getting. You're not really sure if your tests are really relevant. So infrastructure as code is going to help you doing that. So there's a couple of other things you want to solve. Who has audit requirements? Audit requirements. People who need to prove that somebody changed something, when, why, how. So how are you doing that now? Manual procedures, people signing off on paper. I mean, I had a lot of discussion with auditors who were like, yeah, but so if this guy can change this, there needs to be somebody reviewing it, and we need to have a lot of paperwork, and we need to sign it, and blah, blah, blah. And we're doing this in code. Basically, every single piece of code is in Git. We can identify who wrote what, when. Git log, Git blame. You can put a review process in place. If your team is big enough and you have enough people who are able to review stuff at a decent speed, if they're not basically sitting in a small team where there's not enough resources to block the pipeline, then you can put review in there. You can actually say, look, that guy can only commit to that Git repository. The same with the parameters. You can put on Git level permissions on who can write or read a certain repository. So your audit and your compliance can be put in place. And then you can easily figure out, I mean, this is a trick by Laurent Bigonville, what he does, and this is an example of Puppet. In the Puppet run, we actually have applied configuration version, and this is the Git hash. So you can uniquely identify where a build came from. in the pipeline that builds the Git repository that deploys the Puppet code, there's actually an echo git commit to Git version, and that Git version is being included in the config version of the Puppet master, where it says, look, config version is this file. So every single Puppet run you do on that moment, you will identify this is the build we're running. It's from this Git commit, and you got one-on-one relation on who changed what where. And your audit chain is solved. Try doing that with manual hackers on a platform. So security, we said. This is a slide for a bunch of you might be too easy, but this is an example what Puppet does when you modify a file. So this is a Vagrant box, it runs Puppet, and basically we put a file in place, myfile.txt, with this checksum as the content. And then I go into the box, I manually modify it. I can do this live with live demos, you know Murphy. I'm not Kelsey Hightower. So when you modify that file, I run Puppet again, it's going to say, hey, this file, I'm going to change the content from something you modified it to the original state I want it to be in. Now this is something auditors will like, because you know now for sure that the platform is the way you designed it. What they won't like is that somebody actually changed the file, but if you run Puppet frequently, and you can do that with any other tool, you will have the platform in a state you know it was in. So a bunch of those developers will say, hey, I want to have my changes in there fast, and I want to be able to log onto a platform and fix it. So that's when you build in a continuous integration pipeline for your infrastructure as code, because this is code. You're doing tests on them, right? You're having a delivery pipeline, so you can ship and deliver the code. And you teach those developers, look, if you do this manually, it's going to break. It's going to revert to the original state. So just like with your Java code or your PHP code, you need to go through the pipeline. And given that this is a Icinga camp, I think this is, for me, one of the most important reasons to do infrastructure as code, fixing monitoring fatigue. To give the example with Puppet, there is this concept of stored configs. And this is a big picture, which I stole from Brice Figueroa, but he knows. Basically, on a lot of your servers, you have a Puppet agent down here. When you define the code, and I'll show an example of the code, you say export a resource. It's going to put it to Puppet master in PuppetDB. And then you have collectors. And these collectors are typically your monitoring systems. So this is a resource which you export. This is a resource which you collect. And what you do now is you write a profile where typically you put in SSH keys, I'm going to export them, or reverse proxy, or your monitoring resource, the resources you want to measure. And you say, export me the fact that this is an Apache with this vhost and this business functionality. This node has disks, I've added the disk, and there's a profile you write. And every single web server you build is going to have that profile with the vhost you put on there defined. Every single database server is going to have a database. You want to monitor the disk space. You want to monitor the speed at which the disk space changes. You want to include the exported tables you want to monitor if there's stuff in there you want to verify. And then on the other side, you have Icinga. And Icinga is going to collect all of those metrics. It's going to collect all of those resources, and it's going to automatically build its config file for you. Now you remove a node, Puppet is going to notice, it's going to delete those resources from your database. Guess what? The next Puppet run on your Icinga master, it's going to clean up all those resources. And you won't have resources that are out of sync. You'll have a stable platform where when you deploy a new node, it's going to be automatically imported in your monitoring platform. So this is an example for Puppet Master where we basically check a bunch of things. So there's an Agile server where we use the checks from the monitor community, and we actually export this. This is written in the Puppet profile for the Puppet Master. There's a config file, there's other servers, and actually there's like 5 or 10 services which we define in the profile. And each time we set up a new Puppet Master, it's automatically being monitored. So we built in code a profile which defines the standard ways of how you use an upstream module, how you configure backup, how you configure log rotation, where you ship your log files, and how you monitor it. Now compare that to how a legacy environment works. A really blue shop takes some proprietary tool to bootstrap a machine. That takes like 3 weeks from the request, can be done by one team. So the box is there, the VM is there, empty. Then another team takes over, completely different tool set, and it installs 5 tools and patches. Then another team takes over, and it installs monitoring. And then yet another team takes over, installs some basic form of monitoring, which has absolutely nothing to do with the application that's being put on there. And then there's Team Z who actually deploys the application manually. This is what a traditional enterprise looks like. This is why it takes you 6 to 9 weeks to get a machine provisioned. And guess what? By the time it's being used, it's completely irrelevant. This is why if legacy organizations start thinking about the cloud and they don't use infrastructure as code, they will fail. And they do fail. So when we talk about infrastructure as code, a lot of the things in there are already existing. There's people who say, well, we need new tools and new ways to deploy applications. But what's an application? It's a package with configuration and a service you need to start. In Puppet, we call this the PCS pattern, and it's pretty much working for every single application, whether it's a Java application, whether it's a C application, whether it's Go. It's pretty much all of them, except if your developers or your upstream manufacturer has not split out a configuration. So if you define your software as a package, RPM, Debian, whatever, and you deploy it that way, then infrastructure as code today solves your deployment strategy. It solves your problems. But that was just one of the ways to solve things. I think today my message really is that infrastructure as code, although Ulf Manson at DevOps Days Rome, when he started this Ignite with slides drawn by his kids, was more looking into, well, the way that he had found to build a flexible infrastructure with Sensu for his use case. Infrastructure as code is actually why people started loving monitoring again. It is the automation part that brought back the monitoring to a level where we like doing it, where we spend time with it again. So infrastructure as code solves a lot of problems. It improves security, it gives us back the love we have for monitoring, and it actually provides people with a faster and a better and more stable way to deploy software. But it's still code, so we need to treat it like code and not just hacking in production. Right, Bernd, how are we doing on time?
Very good.
Very good. Any questions? Or do you guys all need coffee because you're still asleep?
Very good. Questions?
One question.
Yeah, you mentioned testing as part of the infrastructure as code. Is that something that's a special tooling for that, or is that just like testing whether something is installed? What do you consider testing?
Okay, so the question is, I mentioned testing, if that's some kind of special tooling for that, or if that's just verifying. There's, depending on the tool set you choose, a lot of different tools out there. If you're working in Puppet, it's usually RSpec or Beaker. If you're working in a Chef environment, I think it's Test Kitchen. But if you, that's for mostly unit testing of the code. If you're looking at a more general purpose way of testing, you could also look into server spec, which kind of tests if I spin this up, does this really give me an Apache with a web server listening at port 80? Or one of the things I prefer to do a lot is to do the actual integration testing by using monitoring plugins. And say, I spin up a box, this is the check which I'm going to run in production, is the way it runs now also functioning? And that's a successful test in my pipeline, so I can promote to the next stage. And it kind of depends on where you want to put the effort. I'm more a fan of focusing more on integration tests because I can reuse them in production later. But I see also a lot of value in people writing unit tests for their Puppet or Chef code.
I use Ansible.
You use Ansible. Then you have to wait till Tushan takes the stage and tell you how the Ansible guys do testing, or not.
Yeah, maybe.
Yeah, maybe.
Super excited.
So that's, well, my response to what about Ansible, then I say, yeah, maybe. Okay, in the back.
Just a small question. What would you prefer in the case for also now having you focused on Puppet, Ansible, Chef? What's your favorite?
Having focused on Puppet for the past 8 to 9 years, having looked at Chef and liked very much what I saw, but never actually got around the time to replace a large code base and move to Chef. Having looked at Ansible and ran away screaming and crying, because of all the functionality I'm used to in Puppet, which isn't there, thinking like, Toshan, correct me if I'm wrong, but how would you do exported resources and stored configs in Ansible? No, they're not facts.
They're not facts, but that's what you can get out of it. And out of your inventory.
Out of your inventory, yeah. So is Tower open source yet? No.
You could designate the task to another host directly from your playbook in Ansible.
Yeah. How's that for scaling?
Don't want to talk about this.
So he was asking my preferences, so I'm kind of... one of the things I would love to spend time with is Salt Stack, but I guess that's pretty much the ecosystem that's out there. The rest might be charming, but nobody cares. CF Engine.
MGMT.
MGMT is a special case because you still need Puppet or Chef to run it. It's still not a full DSN. So Frank is working on a lot of cool stuff together with James Shubin, and it's definitely a tool you want to keep an eye on, MGMT. It's a pain to Google, but Google for just James and you'll find it. And Felix Frank is doing a lot of interesting work in actually getting Puppet code to run on it. And the rumor that he's also working on a Puppet to Chef translation engine is wrong. But he's working on a lot of fun stuff. So yeah, MGMT is definitely something which might become interesting in the future. If I would have a complete greenfield today with no legacy and with time on my hands, I would probably either take Chef a spin again or look at Salt. But if you ask me today, build something fast, I'm going to go for Puppet because that's what I've been doing for a very long time and I feel really comfortable in. So yeah, that's my honest response to that. Any other questions? The rest of the discussions we should have over beer, except for you guys having the beer and I'm not drinking, but...
Wait, what?
Wait, what?
Right?
All right. Coffee?
Thank you. Thank you very much.